Hi, Miss Priya.
Hi Subi, how are you Subi?
Good. How are you?
Good ma. How was it? Was it okay regarding radiance and stuff? Were you able to do?
I was kind of busy this week. We had a bunch of projects.
Oh, at
What?
school?
Yeah,
I see.
I found it easy.
You found it easy. Okay, that's good to know. We didn't do piecewise function last week, right guys? Did we do piecewise functions? No, right? Hey, how is your geometry coming along, Rishit?
I'm done with four tests now.
Oh, you're done with?
Four tests.
Oh, that's nice. How did you do?
I got 100 on all of them so far.
Oh, nice. Easy?
Yeah.
That's good to know. It's really nice to know. Hey guys, this will be the last time we are meeting. Huh? This will be the last time we are meeting before the summer. Okay. When is your geometry getting over, ma?
I have until July 15.
Okay, you haven't. Okay. Oh, before that, you need to complete both, is it?
Yeah.
Ah, I see. Let me. 1 second, ma. I will get everybody in and then see. Okay, what did we do till now? So basically, algebra 2, Friday. So we have done only till okay, radians and stuff, right? Not much. Okay. Subi, are you done with that? Whatever was given?
I was working on it, but I'm not done with it.
Okay, so you're all taking it easy. Okay, I see. Okay. Let's see. Wait. Sequences. Okay. Now I really want to go to unit circles. I really want to see, but that's not enough. Okay. Okay. Let's see radians. Unit 8 review. Let's quickly see one or two questions I'll ask. Okay, see whether you're able to do this quickly. Just a review. We'll do this. Okay, then we'll go to at least one more topic I want to cover today. Okay, so let's see. Let me share my screen. Avni, were you able to do the homework or did you see the homework?
I looked through the homework, but I wasn't able to actually finish it.
Oh, finish, but did you understand how to do?
Yeah.
Hey, Anisha, how are you, ma? All over? All the tests over?
Yeah.
Okay, let's go ahead and do the conversion to radians for these. Convert the radian measure into degrees. We'll do that. And then coterminal angles as well we completed, right? Let me take a couple of them. We'll do this. I just want you to do maybe, yeah, actually only two questions are there. Oh wow. Okay, go ahead and do. Yeah, we'll do these questions as a review, and then I'll move on to I'll move on to piecewise functions. Okay, go ahead and do this. As and when you get the answers, you can let me know. Once we finish this, I'll go on to piecewise functions. So at least the basics we'll cover. Convert each degree measure to radians. There are two questions. Convert a radian measure to degrees. Two questions on each. Sooner the better. Or if you want, you can go ahead with doing one. That's also fine. If you are doing one, I just want you to do these. If you're doing one, I would like you to do these. Please have the question numbers when you send in the answers. Once you finish this, we'll go to piecewise functions. Let's see if I can go to step. Greatest integer function is another thing that you can learn before we get on even. Let me know, guys, if you need help immediately. Let me know. Let's finish this as well as the piecewise functions today. Do you have it? If you need help immediately, let me know on anything that you need help with. Okay, I will go ahead and correct quickly. Okay, so this is going to be 1 2 3 4 9 10. Oh, okay, you're doing Nisha, the 1 and 2 is correct, ma'am.
Is 3 wrong?
Yeah, 3 is correct, ma'am. Yeah, see, if you want to pick and choose, just choose the red tick marks. Okay, I've given the harder of the two. It's enough if we do one of them. I feel like it's a review, right? So if you know the basics, it's enough. And then after this, we'll get into piecewise functions. Subi, that's right. You can go to form. Arush, what are you doing? You there?
Yeah. I've just been doing all of them.
Okay, that's great. Then I'll check all of them. Oh wow. 10 is. Wow, good ma. Have you studied greatest integer function or least greatest integer function? No, right? Star case graphs? Yes, no. Tell me, guys.
What?
Have you studied greatest integer function?
I don't remember hearing that, so I don't think so.
Okay.
Floor and ceiling function.
Floor and seal, yes. Have you studied?
Yeah. I did it for the MC, not school.
Oh, okay. You did for the
AMC.
AMC. Okay.
Yeah.
Oh my gosh, that was too quick. Yes, Arush. 3. I'm checking Arush. Oh my gosh, that was so quick. Okay, I should be able to check now quickly. Three is 30. That's interesting. 3 is not 30, right, Arush?
Oh, do you want like a positive or a negative value?
Negative.
Oh, okay.
But what is given? Yeah. Minus 23 pi by 6 means.
I think I did that one wrong. Well, let me check.
No, exactly you need to convert. You cannot give a coterminal angle. Tenth one is tenth one is incorrect, Arush. Yeah, 10th one is incorrect, Arush. The third one is incorrect. Correct, Masu Beetle, whatever you have done. Anisha, I'm checking from 10 now. I did previously. Oh yes, you're doubtful on 11th, but that's correct. Yes, correct, ma. Correct. Just choose the negative angles, guys, if you are in doubt. Once you finish the review, we'll go to the piecewise functions. Anisha, 4th you did, huh? 14th க்கு அப்புறம் 4th. Correct, Anisha, that's right. Subi, okay, 10th. If you just understand, it's enough. Subi, it's 248, right, ma? 249. Why did you put?
Sorry, I meant to put 248.
Okay, no worries. We'll go ahead. What else is there? Yeah, just the yeah. We don't need to do all, guys. We don't need to definitely do all. My intent was only 2 per type. This is what we did last week, right? So I just wanted to revise and state the quadrant in which the terminal. Okay, let's see. Avni, are you able to do, ma?
I submitted my answer.
Did I check?
He didn't check mine yet.
Yeah, that's what I thought. Hold on. Okay, 17th. All negative ones, if you do, that's enough. For some reason, I didn't see your answer. That's why I didn't check. Oh, yeah. I got it. 10th 168. That's 10th is incorrect, ma.
Okay, I'll double check.
11th is correct. 14th is correct. 10th is incorrect. What is 10th? Oh, positive and a negative coterminal angle, right? Oh, positive.
Oh, I think I understand what I did wrong.
Did you add 360 and subtract 360?
Yeah, I accidentally added 180 instead of 360.
Oh, okay.
But yeah.
Yeah. As long as you know the concept, I'll move on, guys. If you think you are good, we'll move on. Rishit, are you able to try?
Yeah, I'm doing them. I'm almost done.
Yeah. Let me know if you need help. Otherwise, you can go ahead. Finish, I'm checking your 12th. 14th, correct. Anisha, correct, ma'am. Did I check your 9th one, Anisha?
No, I don't think you did.
Yeah. 250. Yeah, that's right, ma. Anisha, whatever you've answered is right. 14 quadrant to 14th. Yeah, Subi, whatever you've answered is right. So if you have a good idea, then I can move on. If you say, oh yes, I can move on. If you need me to do it, let me know. You can let me know in chat, guys. That's also fine. I'll just move on. Just message me if you feel confident, I'll move on. Let me see, I also want to get into this greatest integer function. That's such a good thing to know before you go into. First let's do this and then let's do that. Yeah, this is a good one to do. Can we go ahead? Guys, I'm waiting for your confirmations. Feel free to let me know. I have a okay, thanks. I got only one from you. Can I move on? Let me know what each of you feel, right? Based on that, I'll wait or go. Yeah, Arush. I got yours. Subhi, Avni, Rishit, are you comfortable?
Yeah.
Okay, can I move on then?
Yeah.
Okay, good. Let's do the. Let me erase all these off. What did I want to do? I wanted to do piecewise functions. Oh, yes. Give me 1 second. Let's do this. Okay. Did we start piecewise functions last week, guys? Did we start piecewise functions last week? I'm going to stop screen share. Why is it not erasing anything? Okay, that's better. Did we start piecewise functions last week? Please answer.
No.
We did.
No. Okay. Huh? Did we, Subhi?
I don't think so.
Okay. So piecewise function is nothing but, see, if you have a function, right, break it into pieces, piecewise functions. The name itself says piecewise functions. Piecewise functions. So basically, let's say you have a line, okay, then you have a constant function, then you have a parabola. This is a piecewise function. You can define a function from here to here using a line equation. Then from here to here, you can define the same function using a constant. And from here to here, it's a parabola. So 3 different equations will be there to define a function. Okay. An example I will show you. Example would be like this. See here. G of x will be equal to minus x square minus 5x plus 2 when x. This is how we denote it. Okay. So see here, we use this curly braces and then we say the equation, then the domain. Okay. Again, x cube minus 5x for 1 less than or equal to x is less than or equal to 11. And then minus 3x minus 16, x greater than 11. So what do you expect this to be? So basically it's a inverted parabola for x less than 1, x less than 1. It's something like an, I don't know what it is, but it's an inverted parabola. And this one is a cubic function, right? This is basically a cubic function. So it is a cubic function, and after that x greater than 11 is a square root function. So whatever, wherever it meets, right, doesn't matter. So that's how it goes. We don't know. Let's say it might be like this, and after that it's a square root. You know what? But it is square root, but it is reflected on the x-axis. When you look at it, it's reflected on the x-axis, or yeah, it can be like this. So it can be, so 3 functions together, right? We don't have to graph it right now, this one, okay, but slowly we will do as well. So here let's go ahead and try. What is if I ask you, let's say if for the domain x less than 1, you'll use this equation. For the domain 1 to 11, you'll use this equation. For the domain greater than 11, you'll use this function. I have a question. So what will be g of 11? G of 11, what will be g of 11 from these equations? When you closely look at it, right, this is less than 1. From 1, if they ask you g of 1, you have to substitute 1 in this equation and find out, because for 1, here is the domain and that's covered by this equation. So till 10.9999 you can use this equation, and for x greater than 11 you can use this equation. What then is g of 11?
Would it be undefined?
Yeah, does not exist. Makes sense? So here, how about g of minus 1? Can you find out what is g of minus 1 and tell me? I just want you to find out what is g of minus 1 and g of 1. Just the two. Come on, guys. So when a function is broken down into pieces and are given equations and is written in this form, they are piecewise functions. G of minus 1 and G of 1. We'll move on to draw. Okay, once we are able to find this out, right? What next? Let me see. No, I don't want this. This is the one I want. I really want to see. Okay, let's see. Yeah, we will see. If possible, I'll finish. I'll just touch upon this piecewise function, then go to greatest integer function. It'll be nice when you go into pre-calc. Did you get this, guys? Just send the answer to me, then we'll move on to the next. It's not a hard one, right? 4 and 6. Is it? Each of you have different answers. I don't know. Anisha. Okay. Minus 1 and 1 I asked you, right? Correct, Anisha. Minus 1 is correct. 1 is incorrect, ma.
Okay.
Minus 1 is correct, ma, Subi. 1 is as well correct. Arush, Rishit, can I get your answers? Avni, did you get a chance to do?
Yes.
Oh, yeah. Sorry, yours is right, I said, right? Subi, did you get a chance to do? Yeah, you did. Okay. Only the sign was a problem, Anisha. Did you check?
Yeah, I saw
It might have been a typo. Okay. Rishit and Arush, where are we?
I'm kind of stuck.
You're kind of stuck. Okay, see, just let me know, then I can do, right? So g of minus 1, right? Which equation would you use? Minus equation will fall in this domain. So you'll just need to substitute. Find out the equation and just substitute. Suppose minus x square is, they want minus 1. So substitute x equal to minus 1. Minus 5 and then a minus 1 plus 2. So that will be minus 1 plus 5 plus 2, which will be 7 minus 1 is a 6. Now g of 1. 1 means you will use which equation? G of, what did I do? G of minus 1. Yeah, G of minus 1, I use this equation, right, Rishit? So G of 1, where does it fall in? G of 1 belongs to this. So this equation needs to be used, x cube minus 5x. So you need to substitute 1. So 1 cube minus 5 times 1, that will be a minus 4. Can I move on? So that's an easy one. Let's go ahead with the next one. How about this? Let's try to draw the graph of a piecewise function. Okay. Now I think you know this, guys. If you don't know, then I'll help you. Okay. You need to be very careful with the hole and the shaded dot. It goes up or goes down, that's important. Okay, you know how to draw a linear equation, linear line equation, you know how to graph it, you know how to draw a constant function. So this is just a combination of two lines and one constant function represented as piecewise function in different domains, right? So would you be able to graph this quickly? Would you be able to graph this? You want me to graph it? I'll graph it as well.
Do we draw on paper and then show you?
Yes, please. See, the very important part is this will have a hole at minus 2. This will have a dot at minus 2 and a dot at 3. This will have a hole at 3. Makes sense? It should be a function and it should pass the vertical line test.
Miss Priya,
Yes, ma.
may I use the restroom?
Yes, please. Do you get it? I can draw and show, but let me know if you want me to draw it on the board as well. Absolutely fine. The next one would be, given a graph, you should be able to write the equation. So it will be a combination of all. Rishit, I'm checking. Rishit, hold on. Rishit, I'm not able to see Rishit. You have to bring it in front. I don't know. Can you take it up a little bit? Something doesn't feel right to me though. Yeah. 1 second, that doesn't feel right to me, Rishit. Because see, this is only till minus 2, right?
Yeah, I forgot the domain restriction.
Yeah, so that is still only minus 2. Minus 2x minus 1 means what are the points? Let's say before minus 2, I'll plug in points and check. I'll plug in 2 points, then I'll draw a line, right? So I'll plug in minus 3. If I plug in minus 3, what happens? It will be 6 minus 1, 5. Okay. Minus 3, comma 5. 1, 2, 3, 4, 5. Minus 3, comma 5. And then I have to stop at minus 2. I know. But then where to stop? I don't know that. Okay. So if I plug in minus 2, what happens? Plug in minus 2 and see. So 4 minus 1, 3. So minus 2, comma 3. That will be a hole. Okay. So this goes like this. Now the next one is a constant function. At where? Constant function at minus 2. That's a constant function. That will be a dot from there till 3. 1, 2, 3. Till 3, it's a straight constant function. And then what? X greater than 3. X greater than 3 minus x plus 5. So let me plug in values. 3. Let me plug in 3 and see. Where should I have the whole? I need to understand, right? So 3, if I plug in 3 into this, right, it will be a 2. And then if I plug in 4 into this, right, it will be a 1. So 3 comma 2 will be a whole. 3 comma 2 will be a whole. And then 4 comma 1. You see here? So this is going to be like this. Any questions? Any questions, guys? Yeah. Abiding by the domain restriction is what is going to make it so important. Okay. Now let's try this one quick. One more, and after that, given a graph, you should be able to write out the function for me. Okay. So let's see this one. F of x will be equal to, let's do this one. This is a good one. Minus, see here everything comes together from algebra to algebra 1, everything comes together. So x less than minus 1, you should draw a transformed absolute value function graph. Okay. For the domain minus 1 to 2, minus 1 less than or equal to x is less than or equal to 2, you should draw a line. Okay, this is also a line, but for x greater than 2. Do you want to try this one? This is the last one. Okay, and after that, given a graph, you should be able to write out. Let's see.
Miss Priya have to go.
Yeah, you can. Okay. Yeah, Arush. Let me know if you're not able to draw, then we'll go to given a graph, you'll write the equation. Go ahead. Are you able to draw, ma? Or should I draw it on the board? Please let me know. Anything is okay, guys, for me. I'm checking, Rishit. 1 second. I don't know what. Okay. 1 second. I'm checking. Wait, Rishit. Give me a minute, Rishit. Please, please, please. Oh, that is nice. 1 minute, Anisha. I'm also checking. Wait, ma. 1 minute, Rishit. See, okay, it should pass the vertical line test. Is it passing the vertical line test?
Oh, I forgot that part.
Yeah, it should pass the vertical line test clearly. Okay. Well, okay, guys, I'm going to draw. Okay, I'm going to draw and show, please. There is some problem in all the graphs. I can clearly draw it and show where was the problem. Okay. You're thinking that you should show a continuous graph. No, we don't need a continuous graph here. Okay, so this one, right, let me first draw this. This is so easy, right? -1 to 2. -1, 1, 2, 3, 4. -1 to 2, it's minus x, right? Minus x means, let's suppose y will be equal to, x will be equal to -1, then 1, then -2, 2. So that's what it is, right? So -1 is a 1, -1 is a 1. Okay, -2. Oh my gosh, I cannot put -2 in here. So 0 is a 0 when you think about it. And then you put a 1, then it is a -1. Okay, that's what it is, right? So this is this, okay? This goes like this, okay? But there is a dot, shaded dot in here. We are done with this. X greater than 2, right? See, it goes like this, but greater than 2. Here till 2 it goes. Let me show you that as well. Till 2 it goes, right? There as well, if you put a 2, what happens to that? It will be a -2, okay? So we have 2 comma -2. Till there, you have the dot. After that, what happens? It's equal to x, right? So at 2, if I put 2, 2 comma 2, 2 comma 2, okay? This is a hole, okay? 3 comma 3, that's a dot. So it goes like this. Any questions still here? Okay, but the problem was only here for all of you, right? The third one was the problem. This one, okay, think about, we have to draw it for x less than -1. So let me identify what will happen at -1. If I put a -1 in here, it becomes a 0, 0. 0 plus 1 is a 1. So if I put a -1, I end up with a +1. -1, a plus, I end up with a +1, right? But the thing is, I cannot do that because that's a dot, right? It's a dot, meaning it's not defined at that point, right? Now, let me try going ahead with a -2. What happens there if I put a -2? It'll be a -1, but then a -1 plus 1 will be a 0. If I put a -1, it'll be a 0. If I put a -2, it would be a 0. So do you see here, -2, it would be a 0. Any questions on that? Any questions on that? Let's see one more point I want to see. -2. I just want to see, guys, give me a minute. If you put a -2, what happens there? -2 plus 1 is a -1. Then absolute value of that would be a 1. Then -1 plus 1. -2 is a 0, correct? If I put a -2, -2 plus 1. -2 plus 1 is a -1. Absolute value of -1 is 1. Then a -1 plus 1 becomes a 0. So this is a point. -2 comma 0 is a point. However, for -1, right, if you put a -1, it ends up with a 1. -1 comma 1, it's a whole for this function, right? So that is, moreover, it's an absolute value function as well. So it is going to have something like this. So this is going to go where? I want to put a -3 and see what happens to a -3. -3 plus 1 becomes a -2. But absolute value of that is a 2. And then a -2 plus 1 is a -1. So -3 comma -1. It goes like this. So I'll draw it like this. Okay, so it doesn't have to be a full function, but I will draw it like this. Any questions? Any questions? No? Okay, then let's go ahead. I really want to, 1 second guys, suppose if we put what happens at 1? -2 comma 0 is okay. -2 comma 0, -2 comma 1 now. Really? Oh, I gave you a different function. That's the deal. Okay, got it. I gave you a different function. They won't give you such a way that it matches for sure. Okay, shall I move on? Okay, now given this graph, let's see whether you're able to do this one. Okay, coming to understanding whether a piecewise function is continuous or not, it's a little different. How do you say a piecewise function is continuous or not? Wherever there is a skip, right, you don't call it continuous. Okay, let me give you one sample. Wherever there is a skip, you don't call it continuous at all. Meaning, if it is not defined, let's say, you don't call it continuous. Okay. Similarly, let me give you examples, and then you can tell why it is not continuous or why it is continuous. How about this? Is this continuous or not? You guys tell me. Then we'll go to. Go ahead and tell me whether this is continuous or not. Is this continuous, guys? You have to tell me, guys. Is this continuous or not? Is this piecewise function continuous or not, guys? Subi, you want to say?
It is.
It is not, right? X
Oh,
equal
wait.
to 5 is a whole. You see what I mean?
Yeah.
X equal to 5 is a whole. So see, at that point where the function differs, right, I'll always substitute and see. See, here 5 is the culprit point. Okay, less than 5, this is good. Greater than 5, this is good. Great. Okay, but I want to substitute at 5 and c, meaning less than 5, I want to substitute and c. Okay, this will be 6. Okay, greater than 5, what happens if I substitute this? 10 minus 4 is a 6. Great. Okay, both are matching. Correct? Less than 5 and greater than 5. But at 5, it's not even defined. So, f of 5 is not even defined. As a result, this function is not continuous. Okay. For you to measure the continuity, right, the first thing is less than that point and greater than that point should be equal. If they are not equal as well, they are not continuous. They are equal, but at that point when you measure, it's not even defined, so it's not continuous. Okay, so the first thing you'll verify is at those points, right, you need to first verify whether they are continuous. How about this? In this case, what I'll do, at 2, this is 2 is the point which is a controversial point, right? So 2, I'll check. Okay, h of 2, h less than 2, let's say, okay, for less than 2, let me check. Here value would be 3, right? Greater than or equal to 2. Let's see. Let me put 2 and see what happens. At greater than or equal to 2, 4 minus 1, 3. See? So, when it is equal to 2, you see, or greater than or equal to 2, 3. So, this is continuous. There is no skip or anything. So, at that point, this is a continuous function. Okay, now let's go ahead and try one more. How about this? Can you say whether this is continuous or not? Should I make it bigger, guys? Should I make it bigger? Okay. So g of x will be equal to x plus 3, x square minus x, 3. This is x less than minus 1, x greater than minus 1, x equal to minus 1. Shall we try whether it is a continuous or... See, when I look at it, right, minus 1 is my controversial point. Everywhere it's defined. It seems to be defined, okay, because this defines everything. Suppose if it's less than 1, let me try substituting minus 1 here. For less than minus 1, right, what is going to happen there? Let's see. Less than minus 1, it is a 2. Okay, greater than minus 1, both should be equal, right? Then only it is continuous. Minus 1 the whole square is 1. Minus 1 the whole square minus minus 1. So this is 1 plus 1 is a 2. Great. Less than minus 1 is a 2. Greater than minus 1 is a 2. but at x equal to minus 1 it's a 3. How can it be continuous? You see, meaning, see, if this is the minus 1 point, right, less than minus 1 it says it's a 2, less than minus 1 it's a 2, where it's a 2, okay, greater than, I don't know how it goes, greater than minus 1 it's a 2, but at minus 1 what happens, you see there is a hole there, but then it has a value at 3. So the function is not continuous at all when you look at it. See, here there is a hole and then it jumps here and then comes back to 2 and moves on. So this function is not continuous. Any questions here, guys? Okay, now one last question. Let me give you one graph. You're going to draw tell me the equation. Okay, let's try this one. That's it on piecewise function. See, there's a lot more, but at least the fundamental aspect of it we have covered. You know what is a piecewise function. So you know when a graph is given, you know how to write a piecewise function. When equation is given, you know how to draw a graph, you know how to tell whether it is continuous or not. So those are the basics of piecewise function. Now you're going to write the equation for this. After this we'll move on to what? Greatest integer function. That's a funny function. I really want to do that with you guys. Are you able to write the equation, guys? You know how to write. See, this combines everything, whatever you knew till date. Okay, writing the domain is more important than anything else in here. Okay, writing the domain does involve a little bit of work. The left hand side is a transformed what function? Absolute value function. It has a reflection. Reflection, move to the left by 2 and then move up by 4. So you have to write that function for x less than 0. At 0 till 2, it's a parabolic function. You have to be able to get the equation of the parabolic function. And then from 2, it's a constant function. However, at 2, right, it is just a dot there, you see. So you'll have 4 different functions to write. All the domain needs to be covered. Try. Let me know if you want me to write down as well. Oh yeah, Anisha, I'm just seeing your answer. Sorry, ma. Just 1 second, guys. Just 1 second. Yeah, go ahead, guys. Oh, that seems right, Rishit. X is. I'm checking, guys. One second. Square minus. Yeah, yeah. Okay, Rishit. There's one change. Okay, I'll write it for you guys. The way you write it is you're going to indicate just the domain, right? So minus of x plus 2 plus 4. Okay. So x is less than 0. This is for x less than 0. X square for 0. 0 less than x is less than 2. So that is x square. That was okay. But then add 2, right? When x equal to 2, right? It will be a minus 2. X greater than 2, it will be a minus 3. So that would be f of whatever you write. Let's say the function you call it as f of x. Any questions? Can I move on?
Miss Priya, I have one question.
Yeah, please.
The way I wrote my answer, I wrote the domain a bit differently.
Let
Should
me
I?
see, ma. I didn't see yours, honestly. There was one I'm checking. No, you have to write it in inequality notation, ma.
Okay, thank you.
I know you have written in interval notation, correct? Yeah, you have to write it in inequality notation, okay.
Okay.
I don't think it's wrong, but that's not the consensus that's followed. You see, there is some convention that we blindly follow, right, in mathematics. Meaning you don't write, it's like, see, if you are going to write x2, right, it's not incorrect, but do you agree? No, right? You want 2x, right? So just that way. Okay. I can't call it as incorrect, but this is the convention we follow, right? It's like that. Can I move on? Okay. Let me try to just give you a brief of the greatest integer function. It's a nice funny function which I would like to discuss, guys. So let's see. I have it ready for you. Let's see. Okay. See, the greatest integer function as the name suggests, right, it is written like this. Okay. One thing is, it is sometimes called a floor or a seal function. Okay. When you write it like this, this is different, this is different. Okay. So what we are going to do, right, we will only discuss one. Let's see. This is the greatest integer. Okay. For this function takes an integer as input. Okay. Takes an integer as input. Okay. It will find the greatest integer closest to the input without going over. Without going over. You know, so what it does, it rounds off to the nearest integer that's less than the given. Make sense? So let's see. Suppose if I give you 7.35. Okay. Now tell me what is the greatest integer function for this one. What is the greatest? This is the greatest integer function marking. What is the output? Suppose if I give 7.35 to the function's input, right? What output will I get? 7. Suppose if I give it 8.01, what output will I get?
8.
8. Suppose if I give it 5.5, what output will I get?
6.
No, without going over. It should not go beyond 5.5. It has to go to the lower end. You're not going to go to the ceiling. You're going to go to the floor. You got it? 5. Make sense? Okay, now comes the tricky part. If I give you minus 2.5, where will it go to? Where will it go to, guys? What do you think? Please shout out something. Let it be wrong.
-3.
-3, yes. It has to go to the left because -3 is considered smaller than -2.5. Makes sense? So it is going to go to the lesser value. Now, I have this, okay? Let's see what happens here, okay? I'm going to give input -2. I'm going to give input 1.75. I'm going to give input 1.5. I'm just trying to get you the drawing, okay, to show you what it is, okay? After that, we'll stop, okay? -0.75, -0.5, -0.25. Then this is a minus, and then you have 0.0, 0.25, 0.5. Let's see what we have. Okay, what will be the values? Quickly, can you say? 1 minute, I want to write a few more. 0.5, 0.75. I really want to do 0.75. A few more, please. Okay, x f of x. Let me show you the graph as well. 0.75. Then I want 1, 1.25, 1.5. Quickly tell me what should happen here. What will be the output? -2. What will be the output? Tell me, guys, if I give -2, what will be the output? What is the nearest integer lower? -2. -1.75?
-2.
-2. -1.5? It's so funny a function. I really want to draw the graph and show you. -1.5?
-2.
-2. -1.25? -2. -1?
-1.
-1. -0.75?
-1.
-1. -0.5?
-1.
-1. -0.25? -1. 0, 0. 0.25? 0. 0.5? 0. This is very important, guys, for pre-calc though. 0.75? 0. 1.1? 1. 1.25? 1. 1.5? 1. Now we have all the values, right? Okay. You have shaded dot means it's a part of the solution. Whole means it's not a part of the solution. You know till there, right? Now I'm going to draw the graph of this function and we'll stop there, okay? I really want to show you, okay? So let's see this one. Let's find out. So, oh my gosh, what did I do? 1 second, guys, I don't know what I'm doing. Okay, so now let's go ahead and try -2. We'll go to -2. What happens at -2? -2 is a -2. Okay, the function is there. Okay, it is defined. -1.75 is a -2. Okay, it goes till what? At -1, right? At -1, it's a -1. Okay, at -1. So here, see, it's a shaded dot, but when it goes here, it becomes a whole because it has to be a function. The actual function is at -1 is a 1. So there is a dot there. It goes till what? 0. But at 0, what happens? It gets a whole. Now from actual value for 0 is what? Actual value for 0 is a dot. Actual value for 1 is a 1. Okay, 1 is a 1. However, when I draw the function of this graph, right? Dot goes, then a dot. Dot goes, then a dot. Dot and then a whole. See what happens? Do you see, guys? Does it make sense? Make sense? So this is called a step function. And you know the general format? I really want to show you the general format of writing this function because it's such an important function in pre-calc. You should know this, okay? Y will be equal to A times B x minus h plus k. This is the general format. Like a parabola has a general format, right? See, I have not told you about h and k and stuff, but this is the general format and the graph looks like a step. It goes from left to right. The parent function, step function or the greatest integer function goes from left to right with a hole on the right. Make sense? But you know the same graph, I can make it like this. That completely changes the dynamics. Meaning I can have a dot, then a hole. Then a dot, then a hole. See, this is the opposite of this. But then in that case, the A value will be a negative value. Make sense, guys? So the parent graph is just this. Okay, I'll let you go. I don't want to explain the second graph. So just this, it's just called a step function, looks like steps, and it is one of the basic property. Like algebra 2, we studied all the basic functions, right? Like that pre-calc, you really need to know about piecewise functions, greatest integer functions. So I just want to give an intro. Okay, yeah, for now we'll conclude. We'll have a break of 2 weeks and then we'll start summer classes from June 8th. Please tell your parents, and information to you. I will send the details of registration form. If you sign up for summer, great. We'll meet in summer. If you're taking a break, take a break. Oh, and I'll see some of you definitely for the summer. Any questions for me? And if you're writing exams, all the very best, guys. Whatever acceleration you're going to do it well. Okay. And if you're traveling, safe travels to you all. Okay, anytime ping me, bug me if you need anything. What else? That's it from me. If you don't have any questions, we can log off.
Bye, Miss Priya.
Bye, guys.
Thank you.
Bye, guys.